Hello everybody, it's Jordan the Computer Scientist here, and today we're going to go over a problem that popped up while I was learning Big O notation. So as you know, if you watched my last video, I'm currently learning Big O, well I'm not learning Big O notation, I'm learning data structures and algorithms, and part of that is Big O notation. And there was a question that popped up, and I'm going to read it right here. Suppose we want to write a function that calculates the sum of all numbers from 1 up until and including some number n. Now the first thing I did when I saw that question was I paused the video and I tried to do the problem myself, because I feel like that's the best way to learn. So basically what that means is whatever number n is, like for example if n is 6 like I have on my program which you're about to see, it'll add every number up to 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6, and then it'll give the outcome. Let's just put it in and see what happens. So as you can see right here, I let n equal 6 and I let s equal 0. S is just sum. I made a for loop and I let I equal 1 for I less than or equal to n, I plus plus. S equals 0. So s plus equals 1 is going to be 0 plus 1 equals s. So it's s plus 0 now equals new s. So s now equals 1. Now as it goes through the code, I is going to add 1 to itself. So I was 1, now I is 2, s is 1, 1 plus 2 is 3, and it'll just keep doing that until the outcome happens. So as I run my code, as you can see down here, it goes 1, 3, 6, 10, 15, 21, because I console.log s every time that it runs just to make sure that my code was working. So yeah, like I said, 1 plus 0 is 1. So right here we got 1, and then it's going to add 1 to 1, which is 2. 2 plus 1 is 3, which 3 is right here. Then it's going to add 1 to I, which is 2. So now it's 3. So now I have 3 plus 3, 6, and so on. And it keeps going all the way until I hit 21. Now, if you pull up a calculator and you do 1 plus 2 plus 3, etc., you'll actually get 21. Now, let's change this to 3. And then just run the code again. It's 6. Let's change this code to 8. Let's run this code again. 36. Now, there was a shorter way that he did it while I was watching the video on Udemy, and I'm going to show you guys that way. Now this is the shorter version of what he did. He also had another one, but it was kind of similar to mine, except he had it in a function. But basically this is the shorter way. He has a formula that basically calculates the number all the way up to n, and here, as you can see, I have 6 in my parentheses. Now we run that and we get 21. If I were to put 8 here, I think that was the other number that I used, you get 36. If I put 3 here, you should get 6. As you can see, it works. Now, from my understanding so far, I haven't finished the whole Big O notation thing because when I was going through it, I kind of got a little lost. So I stopped it because when I get a little exhausted, I stop things and I come back to it when I'm like fully rejuvenated, so I can actually pay attention and learn something. So, but so far from my understanding, Big O notation is just basically the better way to solve a problem. So for example, if you wanted to know what 3 was 3 times, you could do 3 plus 3 plus 3, which will give you 9, or you could just do 3 times 3, because it's just a better way to figure out that answer. But yeah, that's what I learned so far from Big O notation. I'm still going over the course. I'm probably going to do little reviews for myself just to go over what I'm learning, just to reinforce what I'm learning while I'm learning it, so I don't just go over it and never go over it ever again. I really do appreciate all of you. You guys keep me going. I say that all the time just because it's true. So thank you. And don't forget to like, comment, and subscribe. Join my Discord. I hope to be more active soon. Well, now. I hope to be more active now because I'm free. Don't forget to follow me on Instagram and Twitter. My name is Jordan the CS, and I'm going to see all of you in my next video. Thank you for watching.